In this objective, we need to have the LED to light up when the value of the potentiometer is over 400. In order to do that, the potentiometer is connected from ground to 5 volts. That signal of the potentiometer is connected towards the board. The board then sends its value towards the LED, which will turn on or off depending if the potentiometer value is over 400. Also, we have a resistor that limits the amount of current traveling to the LED, which reduces the brightness of the LED. As you can see on the monitor, the value is 395. When I turn it to 400, the LED will light up. If I raise it more above 400, the LED is still on. When the value of the potentiometer is below 400, the LED turns off. In this objective, we create a code in which the line tracker will detect whether there is a black line or a white line. If it's on the white line, it will say white line detected. If it's on the black line, it will say black line detected. But if it's on both lines, it will say unknown. As you can see while I demonstrate, while the line tracker is on the black line, on the monitor, it displays black line detected. When I move it towards the white line is detected on the screen. But when I place the line tracker in between both, unknown will be stated. In this objective, we want the yellow LED to light up when either push button is pressed, but when both push buttons are pressed, the red LED lights up. As you can see in the circuit, we have a pull-up resistor, so it goes from ground to the switch, then the signal, then the resistor to the 5 volts, and it's for both push buttons. And then for the LEDs, we have a ground, then a resistor to reduce the current, which limits the brightness of the LED, and then it goes towards the board, which will light up depending on the signal of the push button. As you can see, when I push either push button, the yellow LED lights up. When I push both, the red lights up. In this objective, I have 3 LEDs and 3 push buttons. Each push button is color coded to each LED. So if I press either one of the push buttons, that color that corresponds to the LED lights up. If I press more than 2, or I press all 3, the LEDs will turn off. As you can see from the push button, I created a pull down resistor, which goes from ground, then the resistor, then the signal goes out to the board, which then goes to the switch, then to 5 volts. So by having a pull down resistor, the logic in the code will not be inverted. As I will show you now, I will test out the buttons. So you can see when I press blue, it turns blue. When I press yellow, it turns yellow. Press green, it's green. When I press more than 1, it turns off. If I press all 3, it's off. Here we have an RGB LED and 3 push buttons. The LED will light up depending on the color of the push button. If 2 push buttons get pressed, depending on the combination, it will either turn on as cyan, magenta, or yellow. If all 3 get pushed, the LED will light off. As you can see, we have created a pull-up resistor. It goes from negative, then the resistor, then to the switch, back to positive. Between the switch and the resistor, we have a signal that goes into the board, and it's the same for all 3 push buttons. Once the signal goes into the board, it comes out of the board from these wires towards the LED. Each colored wire is connected to the color that the LED will connect to. As I will demonstrate, once I push the red will turn on. When I push the green will turn on. When I push blue will turn on. When I turn red and green on, it will be yellow. When it's red and blue, magenta, and green and blue will be cyan. When all 3 get pushed, the LED will turn off. In this objective, I have a photoresistor and 6 LEDs. With the LEDs, I have ground connected to the resistor, then to the LED, then we have the LED traced all the way back to the board. For the photoresistor, I have ground, then a 10K ohm resistor, then that resistor gets sent back to the board, which also is connected to the photoresistor into 5 volts. Here I want the photoresistor to have a certain value in which it will light up all 6 LEDs. For me in the code, I stated as 850. As you can see, the value right now is around 925. Once I cover the photoresistor, all LEDs light up and the value is below 850. Once I let go, the LEDs shut off.